All right, I'm glad you are still here, coming back to talk about arguments. This lesson we're going to look at symbolic arguments, and then the next lesson we're going to look at syllogistic arguments. But this is going to take all this information that you learned from truth tables and from comparing statements and symbolic logic, and now we're going to apply it to looking at premises and conclusions and seeing if there's a logical progression from the premises to the conclusion. So we're going to analyze the arguments to decide, are they valid or are they invalid or fallacies? Okay, and since we are starting with symbolic arguments, we're going to be looking at a set of premises followed by conclusion, which can be written with symbols, hence the name symbolic. So you're going to have these premises that are going to be laid out to begin with, and those are going to be taken to be true. Just to warn you, sometimes you're going to read these premises and they're going to be way out there or false or whatever, but you're going to have to just ignore that, take the premises as true, and see if, given those, you can lead to the conclusion or not. It's kind of like sitting in a courtroom, maybe if you're on a jury or something, and you're sitting there and you're watching the testimonies and seeing the evidence and everything. And when you draw your conclusion about the case, you have to use what was presented in court. You can't use outside notions or other people's opinions or whatever. And that's why, like, when you're on a jury, you're not supposed to read the newspaper, watch the news, or be exposed to the case. And they'll often ask you when you get there to serve, ask you if you know anything about the case before going in, because they don't want you to have any kind of preconceived notions going in. But anyways, because when you're sitting there, you're supposed to take whatever they give you, whatever the judge allows to be admissible in court. If the judge throws evidence out, you're not allowed to use it. So you have to use whatever's there, however outlandish it seems, and use that to decide your verdict. Well, that's the same kind of idea here. So we're going to be carefully looking at the progression and seeing if the progression is valid or invalid. And with symbolic arguments, just like we've been doing, there's always a way to set up a truth table for your test to decide if what you've got going there is valid or not. You could take your premises, put them in symbolic form, and then join them with ands. And then take your set of premises with that conjunction there with the premises and do a conditional arrow to your conclusion. And remember, your premises and conclusion are all in symbolic form at this point. If you do your truth table for this statement, and that final column underneath the conditional arrow has all true values, then the argument is solid. It's valid. Those premises, this premise and this premise, definitely lead to that conclusion if everything under here is true. If there's even one false under here, the argument is invalid. It's a fallacy. Because you want it to be solid. It has to be true in all cases. If there's even one case where it's false, that's it. That's invalid. Okay? So that's how you're going to make these determinations. Alright, so let's look at an argument ourselves and see how to set up the analysis, the truth value, truth table, and everything. Actually, we're going to look at two arguments. And these are in words, so we're going to have to convert them to symbols and go from there. Alright, in this argument, premise 1 is, it is snowing and I am going skiing. Okay, so we have to take this as a statement of fact. We have to take a statement, this person who's speaking, to take this as a statement of fact from them that it is snowing and that person, the speaker, is going skiing. Premise 2. Another statement of fact from somebody. If I am going skiing, then I will wear a coat. And from those two premises, can we draw the conclusion, if it is snowing, then I will wear a coat? just based on the two premises. Okay, let's let P be it is snowing, and I am going skiing is going to be Q. So if I'm going skiing, then I will wear a coat. Well, I'm going skiing, so if Q, then I will wear a coat. Let's let that be R. So if it is snowing, then I will wear a coat. Okay, so in our case, P is it is snowing. Q is I am going skiing. And R is I will wear a coat. Okay, so if P is it is snowing, Q is I am going skiing, R is I will wear a coat. We have, our premise 1 was the P and Q. Premise 2 is the if Q then R. Conclusion is if P then R. Alright, so when we go to set up our truth table, we're going to take premise 1, which is P and Q, and join that with premise 2 using the and symbol, if Q then R. And then we do a conditional arrow to the conclusion, if P then R. So it's premise 1 and premise 2, conditional arrow to conclusion. So that's how we have to do our truth table. We have to do it for that statement. Okay, so our truth table is going to need a P, Q, R. And I'm hoping I don't run out of space here. I'd like to get it all into one slide today. Alright, so P has to have 4 true, 4 false. Q has to have 2 true, 2 false, 2 true, 2 false. And then R has to have TF, 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 TF. Okay, and I'm going to do my truth table a little differently today. I've been doing the truth tables where they're all set up with separate columns, but I'm just going to, there's another way to do the truth table, and if you've been reading your book, you've seen this, where instead of doing new column, new column, new column, and building up your statement, you can go ahead and just write your statement out, and then make columns in the order as needed. First of all, we've got brackets and parentheses. So one of the first things I'm going to do is the P and Q right here in the parentheses. P and Q. T, T, F, 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 F. Then the other parentheses in the brackets is the if Q then R. So I'm going to do that next. So I'm putting numbers showing what order I'm doing everything in. If Q then R, T, F, T, 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 F, T, T. And then finally the and in between those is number 3. And I'll take care of the brackets. T, F, 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 F. Sounds like a really bad report card. Alright, so there's the final column underneath in the brackets for that side of the conditional arrow. Then we got to come over here and do these parentheses. If P then R, we've got T, F, T, F, T, 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 T. And then finally, using this column here and this column here, we have the conditional arrow. That's number 5. If T, 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 T. So that's our final column. That's our answer column. And notice that that answer column is all true. So this argument is valid. Those two premises logically lead to that conclusion. And the truth table shows that it's a solid argument, because that conditional from premise 1 and if premise 1 and premise 2, then you definitely have that conclusion. So, valid argument. Alright, let's do another one. It's like potato chips, can't just do one. Alright, so we've got the baby is crying, but the baby is not hungry. Okay, let's let P be the baby is crying. Remember, but can be used in place of and. You know, for conjunction statements, you can have and or you can have but, however, nevertheless. So, and the baby is not hungry. Let's let that be a not Q. Let's let Q be the baby is hungry. If you want to say Q is the baby is not hungry, that's fine too. You'll end up getting the same truth table result, final column when you're done. Your truth table along the way might look a little different, but the final column will be the same. Alright, premise 2, if the baby is hungry, then the baby is crying. Okay, if the baby is hungry. So if Q, then the baby is crying. P was the baby is crying. If Q, then P. Conclusion. Sometimes you can see 3 dots for your conclusion. You might also see the word therefore. You know, therefore means the same thing. 3 dots. It's telling you the conclusions here. The baby is hungry. So remember, the baby is hungry would be Q. Alright, so for our truth table, looks like we're just dealing with P's and Q's this time. So a smaller truth table than before. Just be thankful we don't have PQRS. Those would be real fun. And they do exist. Alright. So we got to set up. We have P and not Q as premise 1. And then we got to use an and to join that with if Q then P for premise 2. Close the bracket. Conditional arrow to the conclusion, Q. Alright, so I was just reading it over again, making sure it all looked right. So in the brackets and parentheses, let's see this set of parentheses here. We really need the negation Q before we do the and. So let's tackle that first. F, T, F, T. And we're going to use that with P and not Q. So number 2 is going to be this and symbol here. If it makes you feel better to rewrite P right here, you can. P and not Q, so you're going to have false, true, false, false. So we're going to be using that column when we do the and. Then if Q, then P, true, true, false, true. Then we go to do that and. we got to use this column and this column. False, true, false, false. And it's going to be that one with that one. Q, if it makes you feel better, you can rewrite it, but you know what it is, because it's just already there over there. So we have false to true is true, true to false is false, false to true is true, false to false is true. So there's your final answer column. Uh-oh. Let's do asterisks here. Ah. Notice it has a false. Not all true. That final column. So this argument is invalid. It's a fallacy. If there's any false statements in that final column, then your argument is invalid. You can't draw that conclusion. And if you look at it, it makes sense. Premise 1 says the baby is crying, but the baby is not hungry. They've already said in premise 1 the baby's not hungry. So you can't conclude the baby is hungry. So that one, I mean, you can really use some common sense and figure out that it's going to be invalid. But it's good to practice using the truth tables to verify. The truth table is a proof. You know, it's showing beyond a shadow of a doubt this is going to be invalid, and here's why. So it's a good idea to use it. Alright, now after you do a lot of these, you're going to start seeing some familiar forms over and over again. And there are some specific known argument forms that have names because they come up so much and because they're so well known. And if you identify your argument to be in that form, then you can stop right there and not do a truth table and say, I know this is valid because of this, or I know this is invalid because of that, and be done with it. But just be aware, like for testing purposes, you're going to either you have to be able to do a truth table, because there's some questions that you aren't going to fit any of the forms, and on your test there's going to be questions that will ask you for the truth table. But and if you want to cite the form, you need to know the name of the form. I'm not going to require that you know all the names, but if you're going to use that and cite it, then you're going to have to know what the form is called. But here's a chart. Oops. Here's a chart that shows you some of the forms. You have the law of detachment, the law of contraposition, the law of syllogism, and a disjunctive syllogism are all valid argument types. And you can see there the two premises and the conclusion under each of those. And then invalid types are fallacy of the converse and fallacy of the inverse. And you can see the two premises and conclusion for those patterns as well. So if you get an argument that fits one of those patterns, you can just stop right there and say, oh, okay, I don't need to do the truth table. Because you know that if it fits one of these four patterns, the truth table's final column is going to be all true. And you know if it fits one of these two, then the truth table's final column is going to have at least one false in it somewhere. So you don't even have to do it. Alright, so let me go over a couple of arguments where this kind of thing might happen. Okay, let's say you have an argument that premise 1 is if your cell phone rings during class, then the teacher gets angry. Okay, so if P, then Q. So your cell phone rings during class will be P, the teacher gets angry will be Q. Premise 2. I was just trying to darken the dots. Stop it. Okay. Premise 2. Your cell phone does not ring during class. Good for you. So your cell phone rings during class is P, so your cell phone does not ring during class is not P. And then the conclusion, that therefore you could do 3 dots. The teacher does not get angry. Okay, remember the teacher gets angry was our Q up here. So the teacher does not get angry is not Q. Alright, so we have the if P then Q for premise 1, not P for premise 2, not Q for the conclusion. Let's take a quick step back and look at our chart and see if this fits anything in our chart. Okay. So again, we have if P then Q, not P, not Q. And here it is right here. We have a classic fallacy of the inverse. This is an invalid argument. If you go ahead and set up a truth table and say if P then Q and not P, and then do the conditional arrow to the not Q, you're going to find your final column is not all true. So you have your fallacy of the inverse. If you look at it closely and think about it logically, premise 1 is that if your cell phone rings during class, then the teacher gets angry. It doesn't say what's going to happen if your cell phone doesn't ring in class. Who knows, you might have a psycho teacher that still gets angry when your cell phone doesn't ring in class. The initial premise doesn't cover both scenarios. It just covers the scenario of your cell phone ringing during class, follow up, teacher gets angry. So in premise 2, when your cell phone doesn't ring in class, that might be a statement of fact, but you can't conclude that the teacher's not going to get angry. Something else might set off the teacher. Who knows? So you can't use those premises to draw that conclusion. So it's a fallacy of the inverse. Alright, let's look at another one. Let's say we have premise 1. If we take the kayaks on the river, then we see alligators. Just don't stick your hand in the water. Alligator might bite it. It actually happened down here near where I live. A lady was hanging out on sitting on a dock or something in the Everglades at a fish camp. She reached down in the water to get a can out of the water, so it wouldn't be polluting. And an alligator was under the dock and snapped down on her hand and severed her hand. Lovely, isn't it? So just watch where you're sticking your hands. Premise 2, we see alligators. And then conclusion, we take the kayaks on the river. Okay, so premise 1, if we take the kayaks on the river, then we see alligators. Premise 2, we see alligators. Conclusion, we take the kayaks on the river. Okay, so if P then Q, Q, P. Let's go check back at our slide with the scenarios. What do we got here? We had if P then Q. If we take the kayaks on the river, then we see alligators. We had Q, we see alligators. And then P, we take the kayaks on the river. Oh boy, another fallacy. Darn, I didn't pick one that was valid. Another fallacy. This was fallacy of the converse. Interesting. All right. So, invalid. Okay, so if we take the kayaks in the river, then we see alligators. They said that they saw alligators, but we can't go backwards with an if-then statement. Seeing alligators doesn't imply that we took the kayaks on the river. If-then statement is only a one-directional arrow, from the kayaks to the alligators. But you can't go backwards and say from the alligators to the kayaks. Remember that going backwards was the converse statement, and remember conditional and converse are not logically equivalent to each other. So you can't go backwards and have a logical argument there. So it's the fallacy of the converse. No need to do a truth table if you know the name of it. Right, there you go. So there's a taste of symbolic arguments. Learn how to do the truth tables. Wouldn't hurt to learn the names of the argument forms from that chart, because they could save you some time if those pop up when you're trying to decide if something's valid or invalid. Okay, so that's symbolic. Next time we will look at syllogistic arguments, where we have to draw something called an Euler diagram, which looks suspiciously like a Venn diagram. All right, see you soon.